So what happens now? We are bringing a magnet, a bar magnet. So let's call this part S, this part N and S. Likewise, we just call them N and S. So what you can see here is that when you drop the bar magnet, the bar magnet comes down. Bar magnet take a better. So what happens in this loop is that this loop has a magnetic field downwards. This loop has a magnetic field downwards, and downward magnetic field is now increasing. Right? So what happens is the downward magnetic field is increasing. But this guy does not like it. The loop does not like it. Downward magnetic field is increasing, so it doesn't like it. So what happens is the downward magnetic field should decrease. So in order to do that, it should increase a magnetic field upwards. So in order to increase a magnetic field upward, it should make anti-clockwise current and anti-clockwise current. So it makes a magnetic field towards upwards. Right? Okay, so that is the induction process I simply explained. And what happens for the EMF, E is that is BA by T, you know, that's BA by T. So A in this case is not changing, constant, but B by T is changing, right? As it comes down under gravity, and when it comes down, B by T rating, B by T value is increasing. So when the B by T value is increasing, what happens? When B by T is increasing, EMF is increasing. When B by T is increasing, EMF is increasing. And also, when the bar magnet is right in the middle, there is no EMF produced. Why? Because lines go towards this side and towards the opposite side, both sides. The when it's in the middle. So at the middle there is nothing. And as it goes down, what happens? Now the magnetic field towards downwards is decreasing. It doesn't like it, so it needs to increase magnetic field toward downwards. So in order to do that, current has to be produced towards this side, the opposite side. So it's a negative value. So all the graphs seem to be the same. That's the problem. Right, guys? The problem here is that all the graphs seem to be the same. Positive part is there, negative part is there, shape is the same. Right? Okay, so I will tell you the technique of doing this type of questions. Right? You have to go with the area. So when the bar magnet comes down, there is a change of flux. You know what flux is? BA, right? There's a change of flux. So if you get the area of this ET graph, this EMF and time graph. So if you get the area of EMF and time graph, ET, what do you get? It's BA. So area of this graph gives you BA. Area of the graph gives you BA. Flux, that's the flux change. That's the flux change. BA will be the flux change, the flux difference. Flux change. So when it comes down, this is the one who makes the flux. So when it comes down, it changes the flux, and when it goes passing the loop also, it changes the flux, and those two values must be equal, because the same magnet comes towards the loop, same magnet goes away from the loop, so the flux change in both scenarios must be equal, right? So we can write that change of flux coming towards the loop must be equal to change of the flux going away from the loop. They must be equal. They must be equal. So the two areas must be equal. Therefore, positive area is equal to negative area. So this is the technique of doing this question, guys. So in which do you have the positive area equals to the negative area? This one? No. 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 This one seems like make a වැඩි යා මේ පැත්ත වැඩි මේක අඩුයි මේක වැඩි මේක අඩුයි මේකේ minus එක වැඩි plus එක අඩුයි මේකෙත් minus වැඩි plus අඩුයි plus වැඩි minus plus with minus equal when the දෙකේ. So why do you get this shape? You might wonder why you get this shape. Because when it is passing the magnet, its speed is even higher because it comes down under gravity, so speed is higher. So passing the magnet, the rate of change is higher, so the EMF induced is higher, right? So this is the technique. Now this question is a real difficult one because if you do not know the technique, there is no way that you can identify what the answer is.